Our next speaker is going to talk about what we're all hoping for in AI, which is an ROI and a real value to the business. WEKA is a vendor of a data platform. They're a partner of ours, and they're really going to talk about how performance leads to value. So let's welcome Chris Ott from WEKA.
Thank you very much. Fantastic. Yeah, thank you. Thank you, first of all, for being here, for being allowed to present in front of this great audience at this great event. WEKA is very proud to be partnered with Scality, and we hope in the future we will be partnering even more and will be more successful together. I think it's important for two companies that address a very special market at the moment to work together, and 1 + 1 = then 3, and we get more out of it. I brought a particular topic today with me, token economy, and why is that important? We're seeing at the moment the Magnificent Seven, but also many others, pouring and spending a lot of money into AI, into data centers, into infrastructure. And yes, I said AI. I'm going to repeat AI a couple of more times probably. But that's really the key thing of our time at the moment, right? In the 20 years that I've been in storage, I have not felt more involved in our everyday life changes than I have been today with the rise of ChatGPT. So much changes for us, right? And I was almost afraid someone would take my thunder away here, because I also brought some numbers. And we've seen numbers before on how this all scales and what the introduction of AI and the growth of data actually means to us as an IT industry, right? And especially if you're in the storage industry, it's a great place to be right now because data is growing. And I've been using this chart for a couple of years. I think I have one that showed also that in the 90s, a gigabyte was a big thing. In the 2000s, the exabyte was the big enemy of the storage industry, and now we are talking zettabytes. And you don't need a lot of imagination to think of the next one, the yottabyte, being just around the corner, or potentially at some point, a WEKA-byte. So now that explains where WEKA, the name, comes from. It's difficult for me personally to grasp these numbers, to be honest. And so I did the math real quick. In 2022, it's 100 zettabyte. And I wanted to get something tangible. What does that actually mean? So hopefully everyone in here still remembers CDs, 750 megabyte per CD, right? So I did the calculation of how many CDs I could print with that amount of data. And then I added it up and I tried to find some distance that makes sense if I stack it all on top of each other. And it turns out that that's actually fairly close to distance between Earth and Sun. And that's just 1 year of the data that humankind is producing. Unbelievable numbers. And why is this important? Because with all of this data, you have to make use of the data. It's not just storing it, but actually using it. And that becomes even more important in the age of AI. So WEKA and Scality together, I think, are very similar architectures, very modern, and we can help with that. And others that have protocols and architectures that have been developed in the 90s, when a gigabyte was a big thing, are probably not a good fit to address these challenges. Now, to validate this, one of our big customers here in Europe, based out of Amsterdam, is Nebius. They are a neocloud provider for GPU services, and they're using us as the prime tier. They have tested a lot of other solutions, but they're telling us that the way we are designing the architecture of WEKA is exactly how they would design a performance storage tier, and that's why they're using us. And now I'm trying to turn this a little bit into the economic discussion that I promised. So here are a couple of screenshots. I don't expect you to read it, but this is basically NVIDIA saying the more performance you can gain out of your infrastructure stack, and that means server, GPU, network, and storage, the more likely it is you'll be profitable. And I've mentioned this, right? There is some crazy spending going on. On the bottom left side, this guy did a quick back of the napkin calculation how much money is being spent in data centers, and it's surpassing $1 trillion at the moment. $1 trillion. And because I'm a visual guy, I found this here particularly interesting. That's the new Meta data center that they are building in the US at scale, layered over Manhattan. Just to give you an idea how big the spend of infrastructure and compute and all this stuff is. So the sane mind would start to think, is this ever going to return a positive ROI? Right? Because there's so much money flowing into it. And so let's think about it. Let's look at what it is that we're actually doing with all of that capacity, right? With the power, with the GPUs, with the networking. And if you distinguish these three workloads, HPC, AI training, and AI inference, then I've basically mapped this out to different industries and how they're using it. The size of the bubble basically tells you how much it's growing and how much spend is happening in that area. Now, we've seen that in the last 2 or 3 years, training being really important. And now, by the size of the bubble, you can see that inferencing becomes more and more important for our customers. And so that means a lot of that spending is going into inferencing. And if you're able to fix inferencing, you'll be able to deliver a profitable AI service. Now, how does WEKA map to that? Real quick, I don't want to do a product pitch. We have a product that's called NeuralMesh, which is basically software-defined storage. It creates a hyper-performant parallel file system. And then we have additions that you can add to it. One is called Axon. It is basically an implementation of our parallel file system on top of GPUs. So using the east-west network for even more performance. And then we have something that I like as a German, AMG, augmented memory grid. And that does exactly what the name says it does. It augments memory. So keep that in mind for a bit. I want to show you why that's important. So if you look at the bill of one of the H100s here, the bill of material on the left-hand side, you don't have to read all of these things, but basically it costs around 300,000 euros or dollars. And on the right-hand side, you see the distribution of cost for everything else and of memory. So that means if you look at the different iterations from the A100 to the GB300, the cost of memory has been increasing. So suddenly memory becomes really the cost factor because it is a bottleneck. The data, the amounts of data that we have seen that are being created, that are being calculated, have to be stored somewhere. And that is why NVIDIA puts more memory, high bandwidth memory in their servers. Now, what if you can augment that memory with good old-fashioned, high-performant, networked parallel file system storage, right? In short, WEKA. That was a bit clunky. Because what we can actually do is, we have shown in benchmarks that we can perform at the performance level of host memory, providing the latency and the throughput just like the memory in one of these GPU chips. So therefore, you need to spend less on these GPU chips. And I want to show you how we do that. So if you look at this looks a bit technical, but it's basically what we do every day. So on the top of this chart, it's a chat session that you start with ChatGPT. You upload your pictures, you upload a PDF, you fill your context window with words, and then you send it to ChatGPT. And what happens here is basically the model, the LLM, turns these sentences and all these things into machine-readable tokens, which is called prefill. And these tokens live in the memory together with the model itself, and some other things that the GPU needs to run, obviously. And on the bottom side, this is where you actually get the value, which is where the LLM decodes an answer and gives it back to you into actual text. Now, this would be super easy if every one of us had their own GPU, but we don't, because you want to be profitable with this 300,000 euros that you're spending. You put more and more customers on this GPU service. So now suddenly these customers compete for all the resources. And what happens is, at the inference request layer, the prefill side of things, cache gets evicted, and you're basically throwing away tokens that you have produced with the investment of energy and GPU power and all that stuff. Right? So you're throwing away a very good product because you just can't store it anymore. What if you could Oh, there's an animation missing. Sorry, I'll go back. That was deleted. Doesn't matter. What if you could store all of these tokens in the network at WEKA with Scality underneath to scale to exabytes? Right? That would basically solve that problem. You would never have to throw away tokens again and therefore have a higher GPU utilization. And this colorful slide shows how this becomes even more relevant with agents. Every single one of these bars here is one of these chat requests. Agents spin up other agents, and so this becomes a very, very big problem when we see more and more agents and chat sessions overloading over GPU time. Right? And every color change here is an opportunity to actually use cached KV cache, so those tokens that have been created. And if you're throwing them away, you're throwing away well-produced goods, which is in this case a token. Now, I can tell these things in theory, but we've also practically tested them. So what you're seeing here is two graphs. On the left-hand side is a smaller model. On the right-hand side is a larger model. And then the bars, purple being WEKA, will give you the time to first token, which is one of the important measures when you are inferencing. And you can see that we can actually produce the first token quicker than HBM, so high bandwidth memory, or DRAM. And the lines show you that the number of tokens per second we can create is also at the same level of HBM or even faster. And that is because we never have to recreate a token that has already been created. Right? So a massive advantage. And these terms are the ones that you should care about when you're building AI inferencing services. And I just want to jump onto the cost per token on this as well. So we've seen the other ones, token throughput and time to first token. The cost per token is very important to understand. So what does ChatGPT do today when they provide you with an API? They basically give you different prices per token. And these prices, they basically reflect the problem that I was just describing, right? You have an input price and you have a cached price. So if they already have the token, it's cheaper because they don't have to use GPU. But then, as I said before as well, every 5 to 15 minutes, that cache is probably being evicted and you lose those tokens. And there's an output token price. I found here an example of DeepSeek. I think that is fairly recent. And it shows you exactly that, right? The cached token price is merely 3 cents. That must be 100,000 or something token. And the cache miss price is 10 times that. What if now you could create all of these tokens for the price on the top for the 3 cents and charge your customers 10 or 15? That means you're super competitive with someone like this, and you still make a hell lot of a margin out of it. And that's the point of what we would say is a token warehouse, right? Don't create and throw away tokens, keep them and put them into a warehouse. And if we're looking then at profitability as a general thing, we have done some tests, and I think this is fairly obvious, but being able to store these tokens, not recreate them all the time, enables you to have a higher amount of parallelism on your GPUs. And what this chart tells you is basically here in the middle, the number of users that you can host on a given GPU server and how that translates to a profit. So clearly, the more users you can have, the better it is for your profitability. And if you don't have to spend GPU time on creating tokens, you can have more users. Right? So this, in return, creates then a positive ROI token economy. I have this in 2 white papers on the left-hand side. This is our general architecture. On the right-hand side, the white paper about what I've just said, augmented memory grid. So feel free to take a snapshot here and get the links. And I'll be around at our booth and happy to talk to everyone about this. Thank you very much.